In this video, we will see a problem in electrical circuit, which is a application a first order ODE. Pathway for a binary electrical signal between gates in an integrated circuit can be modeled as an RC circuit. As shown in the figure to the right, the voltage source model the transmitting gate, and the capacitor models the receiving gate. To suppose the resistance is 500 ohm and the capacitance is 10 to the negative 11 farad. If the capacitor is initially uncharged and the transmitting gate changes instantaneously from 0 to 44 volt, how long will it take for the voltage at the receiving gate to reach 33 volt? So at that point, we need to model the differential equation. So we're going to use the Kirchhoff voltage law. So R times I plus Q over C equals E. So here R is a resistance, I is a current, and the Q is charge, and then C is capacitance. So here, and then I is dQ over dt. The infinitesimal, the rate of change of the charge will return the current. So instead of putting this one into I, then we got R times dQ over dt plus Q over C is equal to E. So that's the equation for differential equation of Q, the first order, and linear. So I'm going to use the method of integrating factor. So first, we're going to rewrite this as standard form of linear equation. Then we get this. So Q prime plus 1 over RC, Q of t equals E over R. So that's a P of t, and this is Q of t in comparing the standard form of the linear equation. So mu gonna be E to the t over RC. And so Q gonna be E to the negative t over RC times integral of E to the t over RC times E of t over R. So the voltage source, okay, and the plus C1. So then we get a general solution finally, E times C plus C1 E to the negative t over RC. So now here we assume that E is a constant. So why? Because the problem says that the transmitting gate change instantaneously from 0 to 44 volt. So the E voltage source must be 44, which is constant. So and then the capacitor is initially unchanged, so which means the Q of 0 is 0, initially uncharged. So the initial charge of Q must be 0. So using this, we can figure out C sub 1. So Q of 0 is equal to EC plus C1, because plug in 0 into right here, we got EC plus C1, right? C sub 1. So this must be 0. So C sub 1 must be equal to negative EC. So now then, yeah, so we got, finally, we got particular solution right here. Okay, so then we put the specific values of parameters given in problem into that particular solution. Then Q of t gonna be 44 times 10 to the negative 11, right? Minus negative 44 times 10 to the negative 11, right? Then E to d this right here. So now then this is equal to, simplifying this, we got this one right here. And now then we want to find out the time when the voltage reached 33. So since the voltage is Q over C right here, so 44, we divide this one over C, capacitance, right? So but here then we got this equation right here. Just simplifying this for t, we'll get 6.931 times 10 to the negative 9's power.